Hello everyone, this is Dr. Aeronautics and welcome back for another flight. We're finally back in Microsoft Flight Simulator with the P38 Lightning. We're going to do another celestial navigation trip. This is going to be from the Northeast Corridor. We're going to depart Martin State Airport and then fly south over the Chesapeake Bay until we reach the Atlantic Ocean at Virginia Beach. We're going to follow the coastline all the way down to Cape Hatteras, which is the closest spot to Bermuda. And then we're going to turn eastward and fly an eastward trajectory to a line of position intercept just north of Bermuda. And then we're going to land there. It's pretty nice temperature out there. It's like 68 Fahrenheit or something like that. If we switch over to Google Earth, this is again my library computer. So fantastic news. That basically means that we're going to be able to see all of celestial navigation. And unlike last time, I'm saving my audio in a um, secondary audio track, which means after the flight, if it turns out that my voice was not loud enough like it was last time, no matter what, it will sound good because I have a separate track, which means I can mute the game audio as much as I need to. I can boost my speaking audio as much as I need to. So that's absolutely perfect. So this is our flight path once we get out to um, the coast here. So we'll have a position, we'll reach top of climb, we'll have a position for Virginia Beach, we'll have a position for Cape Hatteras, and then once we turn off Cape Hatteras, when we go off the continental shelf and over about 8,000 feet of water, we'll have our celestial navigation site point 1. This is the opportunity to check ourselves and make sure that we have a good number. This one doesn't need to be accurate. An hour later, we're going to be out here in 17,000 feet of water, and that is where we're going to be doing sighting H2 using the bubble sextant. And this one is the one that needs to be accurate. We're going to use that sighting to get us to the line of position intercept as close as we possibly can. Once we get to the line of position intercept, I have a nav log, which we'll go over in a little bit more depth later. But basically, we have our altitude and azimuth of the LOP star that we've chosen, which is Arcturus. We're going to plot our elevation, and when these two intersect, then we turn on that line of position right here, and then go to reach our descent point, and then descend to the airport, which is on the north end of Bermuda. That's LF Wade. Okay, now going back into the nav log again for a little bit more detail here. So we have our flight plan. The goal of this flight is for me to be able to characterize the performance and maximum range without using the tip tanks. No, wing drop tanks. Yes, without the wing drop tanks. You might recall that for Easter Island to Robinson Crusoe, we used a fuel of 630 gallons. This time we're using 410. That is everything topped off without the drop tanks. And you might be asking yourself, what's the point in doing this? Just always carry the drop tanks. The answer is the speed. We gain something like 40 miles an hour by ditching the tip tanks, and we have a lot cleaner configuration and lower fuel burn. Instead of it being like 100 gallons per hour, we have something like 90 gallons per hour, which is actually really cool. Um, so we have everything very neatly planned out. We're going to lift off right at 0700. The goal is to reach the LOP Intercept at, it's going to be 1000, plus or minus 40 minutes is the goal. And that is to support our celestial navigation here. So I've already planned the shots. At H1 we have Denebola and Kochab. At H2 we have Arcturus and Polaris. Polaris should be really easy because that's our latitude. If I get something way off, then I'm going to know that I screwed something up. So this is actually relatively safe. LOP Intercept star will be Arcturus again, which we've already shot, so we're already set up there. I've set the star 1s to go on the hour at 8, 9, and 10 Zulu, and star 2s to go 4 minutes later at 8:04, 9:04, and there's only one star at the LOP Intercept. And really, once we complete this H2 shot, we're going to start this LOP Intercept shot plotting. And then once we observe I can demo this real quick. Let's say we observe an azimuth of 40 at 0900. That's our first plot. And then at 920 we try it again, and then we find, oh, this time it's 45 degrees. Now you can see it looks like, at 940 we're going to cross it. And then let's say we get 50.5 degrees. Boom, we've just hit the LOP intercept. Then we look at the azimuth, 109. We turn on that azimuth plus 90 degrees, so 199 degrees. Turn the airplane to the right, and we basically go for the allotted number of minutes here in the flight plan. 27 minutes. In 27 minutes we should be directly over Bermuda, and that's how that's supposed to work. Like normal, I've also plotted out our fuel here. We have a headline here, which represents the amount of fuel that we will be burning in particular location of the flight. We have our reserve fuel line. If we cross that line with the ahead line, we should not plan the flight. If this crosses the dry tank line, we run out of fuel, and that's not good. We also need to have both engines running between this time here, which is the one engine return line, and let's see, 8:03. So between here and here, we're going to ditch if one engine fails. Once we reach this point here, if we still have two engines running, we'll make it just fine. Then we've got our safe return point, which is right here. So if we're burning a lot more fuel than anticipated and we need to turn back, we can up until this point. And then we have this section between here and here, which is where we shouldn't turn back unless we know 100% something went wrong. Like, let's say we lose an engine. Well, I'd rather ditch off of Cape Hatteras than ditch somewhere in the ocean near Bermuda. There's a lot more coastline. That's a lot smarter decision to make. And then at about 570 miles out, we reach our no return line. That means no matter what, we're not turning around. Lose an engine, not turning around, still going out, because we will absolutely not make it back to base. Although actually this time I think we can actually turn back out to about mile 800, because half of the flight is flying down the coast. It's really only this section here, so probably the halfway point between H1 and H2 is going to be the deciding factor. Because once you reach H2, there's quite a bit of wind today. If I go to windy.com and turn the particle animations on real quick, you can see that we have a straight tailwind. So, and that's 60 miles an hour. We don't want to turn around unless we absolutely have to. Alright, I think that's it. So I'll pull up my checklists here. I have a paper copy that I can refer to. We can also brief a few more things here. So we'll be doing a max cruise climb, so that's going to be 35 inches manifold pressure, 2400 RPM. Then we're going to do our long range maximum fuel configuration. That's RPM 1900, 27 inches of manifold pressure. That's pretty much the lowest fuel consumption that we can provide. And then we've got our instructions here for the nav log. The one thing that I will say this time is you'll notice that we're doing hourly checks. That is because this time I have elected to enable the wing leveler. It's not really an autopilot that the P38 had at the time, but it's something that could be easily outfitted. The B29 Flying Fortress had this kind of thing. Heck, even my plane today has a rudimentary wing leveler system based off of the vacuum system of the airplane. So if even my plane has it, then we should be able to consider that this sort of autopilot is something that we can do. It's only a wing leveler. It's not a heading follower. It's not a course follower. So all it's going to do is just dampen the rocking motion of the plane. All right, let's go fly. All right, folks, here's our airplane. I really hate how in Flight Simulator, when you talk about time, um, it's not exactly the time that you set. Um, you can ask for 6 a.m. UTC, and then it turns out to be 6 a.m. local. And then you have to go adjust it. And it's really frustrating, and it's really scary, because if you get the time wrong, then you can't do celestial navigation. Okay. So we're supposed to do pre-flight, obviously, but we're going to have to skip because there's no way to go around with a flashlight in Microsoft Flight Simulator like you would in real life. So unfortunately, we're not going to be able to do that. We'll just begin with our cockpit checks. Alright, we've got a serious timetable to keep, so we'll need to move fast. Cockpit check, seat secured, headset connected, canopy close and lock. Flight controls check. Alright, good. Rudder pedals are adjusted properly. Trim tab, we want this one 3 degrees back, right there. And 0 for rudder trim. Our fuel selectors should be on reserve. That's not those are these. Yes, they are. Okay, good. Fuel boost pumps. They are off. Alright, bomb selectors. Normally we'd want them on, but this time we're not carrying drop tanks, so there's no reason to turn them on, so they're off. Let's see, arming switches, we'll make sure that those are in safe. Yes, they are. Okay, throttle cracked. Prop governor full forward. Mixture control. Normally we do it in idle cutoff, but we're actually going to do auto rich because otherwise the priming won't work. Let's see, carburetor air filter, it's not required. We don't have a muddy field. Propeller circuit breakers are on, those are these guys, they are. Propeller feathering switches are in normal. Let's see, clock set. So I think we're in UTC -5. So 1, 2, 3, 4, 5, 6, 26. Yep, that sounds correct. And the takeoff time is 7 o'clock, right? Yeah, it's 0700, so we need to be airborne by that time. Well, at that time, really. Okay, so that looks correct. Our time is finally fixed. The altimeter should be set. Let's see, field elevation at Martin State. I believe I have a field elevation is 22 feet. Alright, so that looks like 2.9 or 3. We're very close to standard. Alright, let's see. Gun switch is off. Wing flaps. There they are. They're up. Aileron boost is on. There it is. Radios should be off. We're not really using radios at all in this flight. And then we'll set the parking brake. How did this get open? Oh, it was on to begin with. Okay, well that's unrealistic. Usually you want to release the parking brake because it releases the hydraulic pressure. You don't want the hydraulic pressure to build up over time. Alright, landing light checks. So we're going to do a couple of light checks at this point. So we'll turn, let's see, we want landing lights. And we get 5 seconds to test this so that we don't overheat things. So we'll turn the battery on. 1, 2, 3, good. I saw it, so we're good. Let's see, wing and tail. There they are. Okay, they're working. Take the battery off. And cockpit lights, I saw those come on, so they're tested, they're working. Alright, we're ready to start the engines now. So we're going to turn the battery switch on, master magneto to on, left engine magneto to both, left generator on, left fuel boost pump on, and then we got a prime, so make sure, yes, we're in auto rich, and we're going to count to, should be count to 5. Alright, we don't want to over prime because that causes flooding. Alright, 1, 2, 3, 4, 5. Release. Okay, start left engine. Alright, let's try that again. Alright, we're probably under primed, so let's try it again. 1, 2, 3, 4, 5. Actually, we need to prime more. let's figure out what's going on here. Sometimes you need to have this open. Let's see if we're flooded. Yep, we're flooded. Okay. I'm not sure what happened there. So, but now we're going to have to open the throttle, and we're going to have to wait until the fuel burns off in order to start. I'm not sure how that happened because we kept trying at various intervals. We tried at 5 seconds, then we tried priming again. It didn't work, so we're going to have to wait a little bit now. Okay, we now have the proper amount of priming, so I'm going to bring the throttle back to the starting position, and we'll go ahead and retry the start here. I hate carbureted engines. Go fuel injected every time. Alright, we're up. Mixture auto rich. Alright, and we should have oil pressure, which we do. Okay, we're good. Now we're going to do the left hydraulic pump checks, so we're going to put the flaps down. And good. Put them back up again for 5. So you're supposed to count the number of seconds it takes, and it should be at least twice as fast with the right engine. Alright, so those were successful. So the right engine, we'll do that now. We're going to do magnetos to both. Right generator, that's on. Right fuel boost pump on. And now we need to be very careful to prime. So let's see how long it takes this time to come up. 1, 2, 3. It only took 3 seconds. That was my problem. Alright, 2 engines up and running. We can finally close that now. Okay. Oil pressure, good. We'll do the hydraulic, boom. Lightning quick. Alright, so that's working. Feather switches, tests. It's working. Radios as desired, we're not using them, so they should be off. Compass switch. Go, that's on. Coolant shutters to automatic. There. Let's see, oil to automatic. Intercooler shutters, we want those open. Test the fuel warning lights. That's in the outer wing. That's the only indication that we have. Test the landing gear warning light. That worked fine. Fuel gauges. We should be full on everything. Yes. Gyro instruments uncaged. Oil temperature. We should now be up to about 40 Celsius or higher. Yes, we are. Oil pressure should be 75 psi, but that you usually need to get about 1200 RPM for that. Alright, a little bit low, we'll check that on the run up. Fuel pressure 16 to 18, also in the green when we're at that. Hydraulic pressure 1100 to 1400. wing and tail on right. And then let's see, we have avionics. Avionics lights on. Alright, now they're on. Dial lights up. Half brightness is only necessary here. Okay, we're going to taxi now, so at this point we'll go ahead and call our pushback. Actually, we need the tablet again. And we got to release the brakes first. And do our pushback. See a dang thing, so let's turn those landing lights on. That should be good. Push back, stop, and close the tablet. Brakes on. Alright, so we're going to test the brakes and make sure that our instruments are working good on the way to the runway. Let's check our time. We've got about 15 minutes, so no rush. position about 45 degrees off the runway heading, which this taxiway is. Set our brakes. Alright, before takeoff. Oh, I forgot to close the side windows. That would have helped with the noise. It's also freezing cold out because it's in the middle of winter. I need... Alt-L is flashlight. Alright, side windows closed with ratchets on, rudder and aileron trim. We want to check those are, let's see. Yeah, about 3-0. Good. Fuel selector should be on the reserve tanks. Good. Full fuel boost pumps on emergency. Alright, bomb selector switches. We already set those. Those are off and safe. Prop governor full forward. Mixture control auto rich. Heading indicator set. So let's see, the remote magnetic compass is reading about 57 degrees or so. That's right about there. Vacuum, we should have about 4 inches of that. Actually, we've got 5, so that's good. Generator switches both on. Coolant shutters and automatic. Oil shutters and automatic. Intercoolers full open. Wing flap up. Dive flap up. Aileron boost on. Landing lights as desired. We'll want those on now. And other lights as desired. I think we're good. I don't see any other reason why we would have that off. But anyway, we got 10 minutes to take off, so let's keep going with our engine checks. So you're supposed to do one at a time, but because I only have a single throttle, we're going to have to do them both at once, but we'll repeat it for realism, looking for different left gauges than right gauges each time. Alright, throttle 2300 RPM. Alright, we're in both, left, right, left, both, left, back to both. Alright, we'll pull the prop governor back, look for a 200 RPM reduction. Good. Alright, voltmeter should be showing about 28 volts, we do. Ammeter's reading under 50 amps, good. Alright, throttle 1200 RPM. And now the right engine. Magnetos, we're in both, left, right, left, both, left, back to both, prop, good. Alright, ammeter's good. Come back to 1200. takeoff is in about 8 minutes, so can sit tight for a little bit, and gonna run through any potential last things in my head that I might need to do. Alright, we're ready to go, so we can go ahead and pull onto the runway now. I don't know how this keeps on opening up. I must be tapping something, but anyway, we'll release the brakes and pull onto the runway now. I did go through the last couple items. The main thing that I had was to do the top of climb shot, which doesn't apply in this case because we're not leaving an island. We've got lots of time before we're going to be completely without land references and whatnot. So we're all good in that respect. The only thing that I did do was I grabbed my type, let's see what it is, AN 5835-1, as well as my, what is it, and I'm trying to read something while I'm taxiing. That's why it's such a mess here. There it is, MB2A flight computers. Both of those are actually ex-military, which is really cool. And they have family connections. It's not just like, hey, I bought it on eBay. I actually have a bubble sextant, but the bubble sextant was just bought on, well, it wasn't eBay. It was, what's the name of that celestial website? Alright, we got 2 minutes. Yeah, I can't remember that website for some reason. I'm really surprised, but they specialize in telescopes and navigation instruments and almanacs and that sort of thing. So it's definitely a good source. They had it professionally restored. The only thing is it has no family connection like the flight computers do. All right, so for the takeoff, we're going to pump and hold the brakes, throttles to 54 inches, manifold pressure, brakes release. We're going to tap the brakes, gear up, throttles 35 inches, and then 2400 RPM on our RPM, and then we'll check the engine instruments at that point, and then turn. We're southeast now, so we'll pick up the bay and turn fully south. We're about 30 seconds from departure now. So we'll go ahead and drop into full idle here so that I can release the parking brake and hold the regular brakes. We'll stay stationary here until ready to go. Okay. Less than 10 seconds. 5, 4, 3, 2, 1, 0. Brakes and hold, 54 inches. Alright, release the brakes. Looking for 80. There's 100 actually. Let's get off the ground. Gear up. Coming back to 35 inches. RPM. The really cool thing about this is when I purchased my plane, I wanted it to be reminiscent of the P38 Lightning, and I got a Mooney, and I did really well. Every time I take off the P38 now, I get the same rush that I get when I use my Mooney. It's really cool. So that tells me that I definitely got the right plane. If I had unlimited money, I'd get the P38. Whoa! Okay, the simulator froze up there. It hung up and stopped responding for like 10 seconds. Okay, well, assuming that that's not going to continue, picking up the bay right about now, and let's see, we're going way too fast. We need to get up to altitude here. That's going to affect our time. We're looking for a climb speed of about 160. Climb checklist, 35 inches, 2400 RPM. Yeah, we should be doing 165. I'm gonna give some serious trim up here. Course is going to be pretty much due south. Passing through 5,000 feet right now. Alright, there we go. There's 160. So this is where we want to be now. Then we should be selecting our next tank. So that would be the drop tank, but we don't have those. So the next one we're going to do is the outer wing. Whoop. Sometimes my mouse wheel slips, and that's what that was. We are continuing westward. We got to fix that heading right now. That wing leveler is going to come in a lot of use, for sure. Engine instruments, let's make sure everything's doing good there. It is. Good. Alright. We need some aileron trim here. Of the aileron trim. Even more. There we go, that's more like it. Alright, we're getting high now. We gotta continue with this checklist. Let's see, landing light off. Wing and tail lights is desired, so we'll turn those on dim. And then climb is continuing above 12,000 feet, so both pumps on emergency, and O2 flew on, blinker check, that's good, and we're going to turn the cockpit heat on. And then last thing, I just want to make sure that hypoxia is disabled, because we're probably going to run out of oxygen. In real life, we just bring a second bottle. Let's see. I'm not supposed to be looking at that. I thought the option to disable hypoxia was here. Well, I really hope we don't run out of oxygen, because that would, and if we do, that no hypoxic effects occur, because again, we just use a second bottle, but I don't think the simulator allows you to do that. And we're done. Now we just enter cruise. That's going to be 30,000 feet. You can see the turbo superchargers lit up bright red there, as they would be in real life. Very cool. Let's see, I believe, yeah, this is Annapolis. We're actually right over the Naval Academy now. That's what this green L-shaped thing is. Check our first waypoint here, top of climb. That's 15 miles further south. We should be there in, I think it was 11 minutes. It's been 8 minutes now. We're definitely going to get to climb later, because we'll get to cruise level later, because of how stupid I was right off of the runway, doing 250 miles an hour, which is not climbing, which is what we wanted to do. Alright, now that we're further away from the ground, I think we can start turning the brightness of the displays down. I can see stars now. Alright, once we reach our critical altitude, we're at about 19,000 feet right now. This is great. Now that I can see the stars, I don't need my attitude indicator anymore. So I can tell my orientation based on the stars. Anyway, I was going to say, once we reach our critical altitude, we'll need to increase the manifold pressure. coming up on 26,000 feet now, so we're going to reach our critical altitude. We're going to keep our manifold pressure up to 35 inches so that our cruise is, or rather our climb is kept constant on our flight plan. Alright, so it's been about 14 minutes now, so I'm a little bit slower. Let's see, Tucson Naval Air Station should be coming up next. I think that's what I'm seeing down here. I see the moon rising as well. Drop down to about 34 inches, come back to 35. Just past 29,000. We're looking for a indicated airspeed of about 186 once we level off. There's 29.5. Giving the nose a gentle push down, coming back to 27 inches, 1900 RPM. Just about leveled out, that's good. So continuing on with the checklist, mixture, oh yeah, we need to move that over to auto lean at this point. Also note the time. So 218. Steering direction here. We're supposed to be steering for compass heading 193. Let's grab the tablet. Put the wing leveler on. Once we get established on the proper heading. So everything other than our heading is perfect cruise-wise right now. We're in perfect power state, leveled off right at 30,200 and stable. That's it. Wing leveler on. Only the wing leveler. Alright, we should do a few other things at this point too. So we'll check our engine instruments here, make sure everything is happy there. Good. I'm also going to try to close up some of these switches here. use some more drag. I'll leave the rest of these guys in automatic. See, we're climbing again. That's because we just removed a whole bunch of drag by closing those intercooler shutters. So that means we're going to trim down, and that will be converted to excess airspeed. Instruments look good. Fuel quantity monitor. So let's see. We knew that we leveled off around 18 minutes into the flight. In those 18 minutes, we're burning about 42 gallons an hour. So in 18 minutes, we would have burned hang on a second, 42, no, it's not 42 gallons an hour, it's way higher than that. So 18 minutes, that would have been 70 gallons. Okay, there's our live line, so you can see where that is currently. Let's see, from here to beach, we're expecting to burn 36 gallons. But this distance means that we've probably shaved some of that off. So we're probably going to burn an additional 20 gallons. So 20 gallons plus 50 gallons. Let's see where we are relative to beach. See a lot of lights ahead, that's got to be it. So we're getting close to Virginia Beach. So let's see, if it took us an extra 7 minutes, that should save 7 minutes of fuel here. So this is going to be 2/3, so about 24 gallons. $24 gallons plus, we'll say 60. we switched to the wing tanks. So 70 and 60 is 130. So I'm expecting that we're going to see the low fuel light for the outer wing any minute. It'll look like that. This is Virginia's eastern shore right here. The US 13 down there, heading towards Cape Charles right now. No, I definitely don't want to unlock the canopy right now. Looks like the wing leveler is not 100% successful in working, and that's just like my own plane. It won't exactly hold the heading, it'll just kind of keep the wings level, so we're still going to have to keep an eye on the heading every now and then to fix it. I can see Virginia Beach right now, and we're right about where we want to be, I believe, if I check. Yeah, we want to be just essentially right over the beach. So that's fine. Now it does look like we're tracking a little bit, just a little bit, out to sea. So let's bring the tablet open here and we'll fix our heading a little bit. Yeah, that's drifted. Alright, we'll turn that off. Get back to our heading of 193. So this stretching out is going to be the Chesapeake Bay Bridge Tunnel. Yeah, it still looks like we're too far to turn this off and turn another 10 degrees to 203. We want to be following this highway. This is US Route 13 until we pick up North Carolina 12 in the Outer Banks. So we haven't seen that low fuel warning light, so let's try this a different way. If we assume that it's going to take the same amount of fuel to climb, that's 42 gallons, it's 42 right off the bat. And then we're at 90 gallons per hour after that. So we'll get a latest possible time. So if we say climb took 42 gallons, we have 110 in the tank. That means we're going to have 68 gallons left. 68 gallons left will disappear in 45 minutes at our current burn rate. So the latest possible time for those tanks to empty is going to be 45 minutes after after 11 minutes into the flight, which would have been 7:11. So 7:11 plus 45 minutes is 7:51. That's 15 minutes from now. Before I forget, it would also be a good time to bring up our bubble sextant, which I haven't done yet, and confirm our index error. It's -4. Let's make sure that our index error is -4. Good. Okay. So we're good. We are so high that we shouldn't need to do refraction correction. Oh, speaking of high, it looks like we're at 32,000 feet. I'm getting a little bit sus that the autopilot is leveling in 2 axes. Is that pitch trim wheel moving? It is. Okay, that's an issue. Well, I'm definitely not touching the yoke for 5 hours. So we'll have to turn the wing leveler off and instead use the heading hold, which is a little bit less realistic. But I mean, come on. If the B29 had nav hold, we should be able to get a simple holding autopilot here. Okay, there's Virginia Beach. So hopefully heading hold will let me pitch down, because I don't want to be up here at 32,000. My calculations are for 30,000 feet. Should be able to check right now with the Dadgummit, are you kidding me? It locks up for heading hold, it locks up the no reason why that should be happening. Can I turn the autopilot off this way and have it still hold heading? So now the question becomes, is it going to hold heading? The autopilot is off, but will it still hold heading? If not, we're screwed. I'm not doing 2-axis. That's too unrealistic. Alright, we're going to be right over our objective. So beach is located right at the end of Cape Henry there. And when this line crosses it, we've reached it. Alright, probably 10 seconds. That's it. Looks like 7:40 is our time. That means we're 5 minutes slower than predicted. That's a lot. Alright, we're now going to steer for heading 189. This is the most civilization that we're going to see for a very, very long time. Alright, and now I'm seeing a highway stretching that way. There should be a highway going south. I do see a couple, assuming those are town lights out there. Whoops, we've turned too far. I'm not paying attention. So let's see, half an hour, we should have burned another 45 gallons. Now we should really be getting those empty lights for those tanks. Okay, we're on course now. So there's an airport down there. See if I can make sense of that. Might be somewhere down here. If not, it could be all the way down in Currituck. But I'm expecting that at some point I'm going to pick up the lights of Corolla. That's a pretty big town. We should be able to see that. I think I can see it right here. And we're still turning. Getting really suspicious. Outer wing, outer wing. Okay, then why have those lights not come on yet? Let's see, we've burned, it looks like we've actually burned 10 gallons out of this one. No, 20, yeah, 10 and 10, so that's 20. So we couldn't have burned more than 90 gallons in total in our flight. Is that what this is showing? No, this is showing we burned 115. And what was our plan showing? Plan was showing that we'd be at 80. Okay, so I guess it's not time yet. But in 5 minutes, if we don't see it, then I'm going to be thoroughly confused. Logging our position, but I'm not allowed to look at it. That's for afterwards, so I can okay, so this intersection here, this is going to be Barco. That's what this is. So that, okay, this is Barco, North Carolina, right here. And then these two routes converge. That happens in Kitty Hawk. So there should be a town before it, Corolla, and this highway under us must be North Carolina 12. And we should be able to see the first flight airport, which is actually where the Wright brothers flew a heavier than aircraft for the very first time. So this is Kitty Hawk right here. Okay, and we're over Corolla right now. Kitty Hawk. This is First Flight Airport right here. this point, it's going to become a lot darker as we go out over the Outer Banks, and then we'll get to Hatteras. That will be really hard to identify because I guess, actually no, because North Carolina 12 will take this 90-degree turn. That will be our indication that we've reached Cape Hatteras. Yeah, I don't think I'm going to use this. This just doesn't seem to be working out, and I've got the airplane trimmed out pretty well right now, so I'm actually happy with how it's handling right now. Alright, 90-degree turn in a road near Kitty Hawk. Okay, that's going to be the end of US 158. And so the first flight airport should be just south of that. Okay, right there. So that's probably the Wright Brothers Memorial. Right there. If I can get the plane to fly absolutely straight when we get out to the open ocean, because we'll have lots of time, I will try to show you guys what a real celestial sight calculation looks like, instead of doing it the fast way, which is just grabbing the information straight off of Skyview Cafe. Which obviously would not have been available at the time. So it's 55 gallons each, right? In the outer wing tanks. I cannot understand why we have not run out of fuel yet. $55. This doesn't make any sense. I mean, I'm happy that we still have some in there, and because that means we're burning less, but I mean, so we're almost at Hatteras. At Hatteras, we should have burned more than what is in the tank. If wait a minute, 113. Am I misunderstanding something? So assuming everything was normal, we would have burned 78 gallons. Okay. Alright, I must have confused myself somehow. Alright, so we get to Hatteras. That'll be 113. Assuming that everything was normal with takeoff and that sort of thing. And the climb. So even then, we would have burned, we know that we burned 20 gallons in the other tank, so this would have been 93. So actually, we might still have gas in the outer wing tanks by the time we get to Hatteras. All right, now we've gone way off. Next thing we should be able to see is Nags Head. That's a pretty big place too. And then we might be able to see US 64. I can't see it. So now we know we've burned about 110, and we got to switch off these tanks before we run out of fuel. All right. Next is Maine. And we get our time switched to Maine. Looks like about 7:58. So that means we would have been 110 plus 110 plus whatever we had in Maine originally. So 20. So 110 plus 20, 130 would be a reasonable guess for Hatteras. Okay, so we're trending a little bit above the live line, but if you extend the trend, we'd still be under the reserve fuel line, so we're okay. There it is. That's got to be 64, so this is Nags Head. Yeah. Now I'm surprised, so we've gone a full hour. How long should it be until we get to Hatteras? We should have been at Hatteras already. Alright, we need to do a true airspeed calculation. Something's a little bit funky. How did that get open again? So we're doing 190 oh, we're also diving pretty quick too. We were at 32,000 feet, and that's not good. We don't want to be up that high. So we do want to descend some, just don't want to dive like crazy. Alright, well, we're going to have to let things settle out here before we can get the true airspeed calculation. Was 190 if I grab my MB2A. It was like minus 55 outside. Minus 55, doing 190 indicated. So yeah, we should be doing 305 true airspeed, and this calls for doing 315. I don't know why it's taking so long. Yeah, we just passed under Nags Head. And now there's nothing. Should still have Route 12 down there. miles, we're doing about 5 miles a minute. So that's still about 8 minutes to Hatteras. Oh shoot, I'm going the wrong way. If this is the case, I'm not seeing anything, so we need to go another 8 minutes from the top of the hour. So we're at 05 now, so at 08 we'd be turning out. Well, I'm starting to think we're there now. Have this kind of shake to it. Looks like a heading of 190. Alright, so I'm starting to think that we're actually there. Alright, so that was the top of the hour, right? I think that was. So that would have been exactly 60 minutes flight time. Which means this leg took 31 minutes. And we might as well do our H1 shot now. So, alright, we're making our great turn now to 106. This is where we go oceanic. I just realized that I should have done my shot. So I've already screwed it up. That's not good. You always do it based on absolute time, not location. I think this is probably a first time issue because it was the first time that I've done a hybrid flight. Normally I've been doing all visual or all celestial navigation. This one's kind of hybridized. So let's get established on heading, and then I'm going to have to regenerate a shot for 320. And that will tell us where we are. FS2020 UTC. Gotta clear all this out now because this is no good anymore. Alright, so we're going to do this in real time. So we need the latitude and longitude of H1, 35, 10, 74, 49. Nebula is at 297 minus 180. So the azimuth is 117. Altitude 5355. Just to make sure I'm checking the location, 35, 10, 74, 49. Alright, that's correct. So now we're going to do Kochab. That should be in the north. Azimuth 3656. Alright, that's been fixed. So we are going left a lot right now. The good news is we've finally fixed our altitude. We're now at 30,200 feet again. Shot, I believe, is 2 minutes long, which means we actually need to kick off the first one at 8:19. Google Earth has been crashing on me a lot recently, so I need to really make sure that I write down the shot offsets. going to spend the remaining time between now and our shot time trimming the plane out, making sure we're good on altitude, but we need to fix. The plane seems to want to go left or right a lot, so I'm going to watch this thing and see where it wants to go and then trim it out. This is arguably the most important thing that we do besides celestial navigation. Alright, we angled a little bit to the left, so I just trimmed right. Minutes to the shot time. Alright, we went right this time, so now I'm going to trim left again. Still going right. We have 2 minutes until we need to start the shot. Still going right. Minute to the start of the shot. Alright, so we're going actually a little faster. We're doing about 196. That's like a true airspeed of 312 or so. That's pretty good. Alright, we seem to be pretty well trimmed out right now. We got about 50 seconds for the shot. Let's see, there's a lot of bright stars to the north, but if I look to the southeast, Arcturus, oh wait, no, we went Denabula. That's going to be that bright star up there. 20 seconds to go. Yeah, you'll see when we do this calculation, assuming that I have the plane trimmed out properly now, you'll see that this is really gonna, if you miss your shot time, it's a huge pain in the butt for the person calculating it. Because the calculation isn't straightforward. No, that what? Screwed that up again. It's going to spend 2 minutes and then it's going to tell me it's below the horizon. So this is going to be about a minute late, so it's probably going to be 5 minutes off. I'm not too worried about that. I'm less concerned about speed and more concerned about my distance north-south. We should be about to complete. FS2020. I gotta be quick. Write this down, and then it's time to 54 degrees, 20 minutes. Alright, we need to load up Coach Out now. So that should go at 21, 22, 23. So we're about 30 seconds away from that. So that's a factor in index error here. So we need to subtract 4 arc minutes from both of these measurements. Or calculations, rather. Alright, so the offset is toward. It looks like it's going to be 20 plus 9, so 29 toward. Azimuth is 117. here's our first line of position. (37°, 13 minutes). So 13 plus 8, and that's towards. 21 towards. Azimuth is 20. So right there. Now in that time, let's see, we flew how many miles? We're doing about 300 miles an hour. So that would have been 4 minutes. That's 5 miles a minute. So 20 minutes, or 20 miles rather. All right, so we're going to transform this 90 degrees to 110. 20 miles. Right like that. So we now need to go back along the line of course 20. Okay, now we draw it at 110. Actually, this is not 824, it's 820 because I just advanced it. Alright, so at 820, our position was here, which is about 35 miles north of east of where we expected to be. So let's see how far off course we are. 7 miles. That's not enough to correct. So that being said, we're going to continue holding our heading, which should now be advanced to 110 because we passed H1. Should now honestly be 120 for a couple of minutes because the plane once again came off. Off assigned heading again. should also get our fuel amount here. So let's see, we switched over to the mains. Looks like we've burned 30 on each side, so 60 down from where we were before. No, that can't be right. Very strange. So I haven't used those tanks at all. For some reason I remember the main tanks being in the whatever. So we started at 90, yeah, we started on reserve. So we started at 93. And you can see we're now down to about 63 on both sides. That's 60 burned. Understand what's going on there. Hopefully we'll get a better reading once we've reached this point. If we don't, we're in big trouble. I really don't see how that could have been reading anything else. I mean, we started with completely full tanks. These are the reserve tanks. We're now in the main tanks. The only thing it will be, it might be the scale. So from here to here is 23. Actually, no, 33. And then from here to here is 15. So it should get a lot more accurate once we get below 60 gallons. But there's not really a way for it to burn more fuel. You know, the engine is at 27 inches and 1900 RPM. And the mixture is an auto lean. There's not really any way that it can be, you know, off by as much as it looks. You know, we're not going to just start using twice. Actually, that looks like 3 or 4 times as much fuel. So it's got to be how we're reading the gauge. That's the only explanation. All right, we have about 25 minutes before the next shot. Let's see if we can put a shot together. Okay, so this is our celestial pre-computation form. This is where everything is done. So I'm going to put my name in here, and then the date, and then the fixed time, which is going to be 0900. And we're only going to do 1 star because this takes a long time. The dead reckoned latitude and longitude will be the rounded version here. So what we'd actually do is we'd select a whole number latitude and longitude. So this is kind of a really bad place because it's it's exactly halfway between 2 lines of longitude. So we'd have to select something on the whole number. So we'd do 35 and 69. So we do 35 north, 69 west. Let's see if I can blow this up so that it's a little bit easier to read. True airspeed is 306. Let's grab from our nav log here. Actual ground speed is about 365. Then we need our track and true heading. So the track is going to be this one. That's going to be 98. True heading is 110. Altitude is going to be 30,000 feet. And every time you want to set up a shot, you got to do this. This is why I normally don't do this. Arcturus. Actually, that's the deviation check. Hang on. I'm in the wrong column. Should be in this one. So we're going to do Arcturus. Then we need the Greenwich hour angle. So for that, we're going to have to open up Nautical Almanac 2024. All right, here's the Nautical Almanac for 2024. We need to go all the way down to December 24th. And it's going to be 0900 UTC, December 23, 24, 25. Well, actually, it's not going to matter for a star. So we're doing Arcturus. There it is. So we need this thing here called the star hour angle, 145 degrees, 48 minutes. So that's in there. Then we need something called the Greenwich hour angle. Actually, I put that in the wrong star. This is a star hour angle that we're getting. 145 degrees, 48 minutes. So this is the SHA here, star hour angle. So now we want to go for the middle one, December 24th, and we want 0900 UTC. We want this number right here, the Greenwich hour angle. 228.23 minutes. To check up on our plane here. Wow, for once we're actually relatively on track, and we got 19 minutes to get this shot calculated. All right. So the next thing that we're going to need to do is amend our longitude here that we're going to use for a prediction. So there's a calculation I'm going to write down that is very important. Star hour angle of the star plus the Greenwich hour angle of Aries, that's that Y-shaped thing there, equals the Greenwich hour angle of the star. So we're going to add these two numbers. 229 plus 145 equals 374 minus 360. So we're at 14 degrees. And then it's going to clock over because we're adding 23 and 48. That's 71 minutes. So that's going to be 15 degrees, 11 minutes. (15 degrees, 11 minutes). Okay. The second important equation to know. Greenwich hour angle of the star minus your western longitude, or added the eastern longitude, equals the local hour angle of the star. So now we want the local hour number to be in a whole number. The way we do that is by assuming a different declination. So let's put our 39 north for assumed latitude in here. Our declination, not declination, there we go, plus east-west longitude, right? So minus west longitude equals the local hour angle. So we need something that's going to get us a whole number. So something ending in 11 minutes would do it. So instead of doing 69 west, let's do 69 degrees 11 minutes. So now we're a little bit closer to the original point that I said was halfway between 69 and 70, 69.30 or so, thereabouts. So then you need to subtract those two. So when you subtract 11 minutes out, that cancels. But then you need to do 15 minus 69 equals negative 54. Add 360 so you get a positive number. So the local hour angle is going to be 306. The other thing we need is the declination of the star. Let's go back to the Nautical Almanac and grab it from right here. Let's see. Arcturus. Where are you? It drives me crazy it's not in alphabetical order. But I know that's because the star chart, it's done in an east-westerly order. Arcturus. There it is. 19 degrees, 3 minutes. And I'm going to add a plus on here so that we know that we've checked the sign and it's the northern star. Let's check up on the plane again. Okay, now we're off a little bit. We've got about 14 minutes until the shot rolls off. too far north for a little bit, so we're going to do heading 120 for a little bit while we run these calculations. Okay, so we have all these numbers here. So what next? We need to open a publication called Publication 249 Volume 2. And this is it right here, 249 Volume 2. These are site reduction tables. This is what we're going to use to be able to figure out where we are. So what we need to do is go down to grab these latitude tables, and we want 35 degrees north. So we're going to go all the way down to latitude 35 north. And this one goes to about latitude 40 north. If you need to go further north than that, then you need a polar version of this called Publication 249 Volume 3. Alright, so we want latitude 35 degrees, so let's find out where the header is. And I'm hearing stuff. No? Okay, we're still on track. Alright, the heading of 35, yeah, this is, okay, right there. It's 34 to 35 right there. This is the start. Alright, so this is declination 0 to 14 degrees, same name as latitude. So first thing we need is our declination. It's 13 degrees 3 minutes. So it fits in the 0 to 14, same name. When it says name, it means sign. So we're at 35 north, declination was 13 north. So we're going to go into this category for 13 degrees right here. 13 degrees, and then remember we wanted the star local hour angle, right? That was the other number that we wrote down. So that's 306. So we're going to go down on this side till we get to 306, that's this one right here, and read off those numbers. HC equals 3644. D equals 34, Z equals 100. Alright, the next thing we need to do is go to a correction table. So we're on page 228. Let's go up to like page 15. And this is the table we want. So we have to correct this star now. And what we're doing is we're going to grab the minutes of declination. 3 minutes. And we're using D in this table. So we want 3 minutes and D equals 34. So this is the row for 3 minutes, and then this is the row for D, 34. So we intersect these, we get 2. So the correction is 2 minutes. We're going to add that. So we have a new HC of 36 degrees 46 minutes. And then you might have seen, if we go back to where we were, there's a rule here. It says local hour greater than 180. Yes, that's true. This is the 309. So Zn equals Z. And you remember we wrote down a Z right here. Zn is the azimuth. So if Zn equals Z, then Zn equals 100. So the azimuth of the star is going to be 100. That's how we got this number here. Now it's going to be a little bit different because I'm using a different position on the Earth. So it's going to be, you know, a little bit off. And then let's go back to this. So the other thing that we need is HC. So we've actually calculated that right now. The other thing that we need to do is look out for our refraction. But if you see here, we're going to be at like 54 degrees. So we're at 30,000 feet. And 54 degrees is halfway between these two numbers here. And that means R0 is 0. So that means your correction is 0, and then you multiply it by this F factor, which is usually 1.1, but if it's 0, it's 0. So there's no refraction correction whatsoever. The final thing that we need to account for is going to be the refraction. So, I'm sorry, not refraction. The index error. So this is what this dome personal thing is. So that's the only thing that we're going to do right here. So -4, -4 for total. You can do Coriolis correction if you want to, but it's not going to be enough to be a problem for me. Motion of body, this is what we do for the LOP offset, but total adjustments -4, that transfers over here. So let's see, the HA, we actually had that written down. That was 36 degrees, 46 minutes, and for some reason I thought it was 54. Subtract, so HC is going to be 36 degrees, 30 minutes. And let's go back to the refraction table again. So 30, 36. Yeah, see, that's still going to be in these bounds for 0. So it's going to be like 0.5. Not really worth doing. All right, we've got like 4 minutes left now. Alright, so I got our actual HC. It's 36 degrees, 30 minutes. And let's see what we got on Skyview Cafe. 39 degrees, 48 minutes. Did I use the right location? 30, 35, 35.69. Make sure that's right. H2, 34, 35. 69.29. 3952. Okay, yeah, so that's right. So I must have done something wrong, and that's precisely why I do these things before before I run the calculation. But we have to do the shot now, and I don't even know why those are green. The autopilot's not running. Anyway, so you basically have to do that all over again for your second star. So everything that we just did and do it right, then you have to do that all over again for Polaris. And that one will know right away whether that's right or wrong. Alright, we got 1 minute to the start of the shot. Let's make sure that we've selected our Taurus. Oh, yeah. That would have been a mess. Alright, we got about 30 seconds. Seconds. 5, 4, 3, 2, 1, starting the shot. We got 38:45. Okay, so this time we have an away offset. It's going to be 63 away. That means we're further behind than we expected. That's interesting, because normally we're further ahead. We should also be on the LOP table as well, but we have to prepare the second shot. So The second one should be Polaris. Yes, it's Polaris. So for that, we would need publication 249, volume 3. And it's one of those things where it's like, you know, it's really hard to fly the plane without autopilot and run a proper site calculation at the same time. There's a reason that they had dedicated navigators on board bombers, because there would basically be no way for the pilot to do everything at once, even with autopilot. And I'm trying to do this without autopilot. So that's one of the reasons why I do that, is because it's kind of like auto navigation. Auto celestial navigation. The other option is I could turn autopilot on and do all the calculations by hand. So it's kind of like a pick your poison kind of thing. Alright, we start the shot at 1, 2, 3. Now. Somewhere on this line, and when we get Polaris, that'll tell us exactly where on the line we are. That's our latitude. Oops, that scared me. That's 12, 22, 32, 28. That's 28.2. Azimuth is 359. Not quite due north. Alright, and then offset it by 20 miles again. 28.2. There's pretty much no reason to offset this because it's like perfectly parallel to course, just about. So 89, there we go. So now we go back 20. And then go to 89 again. Okay, so this is at Polaris 0900 LOP. Okay, so this is the one that's really important. So this is where we were. In 40 minutes, we traveled 191 miles. So we're going to arrive at the LOP Intercept. In twice that time. So LOPI estimate is going to be, oops, shouldn't be typing in there. It's going to be 0900 plus 40 minutes plus 40 minutes. 1020. That's going to be cutting it very close to nautical twilight. It should be okay, but it's going to be close. Also, we can put an observed altitude on this table now because we've just done our first one. So we got 38 degrees, 49 minutes because this chart is not corrected for this, so we have to add or subtract the index error back in again. So it's going to be 38. .82. And there we go. So we'll shoot Arcturus again at 9:20, and we'll keep doing that until we're there. And for goodness sake, we need to get back to. I'm gonna trim way to the right because this is not safe what we're doing. And that reminds me, we were off course enough to make a course correction. So it's time to do that. Actually, it's past time to do that. So we're going to be about here. That's 30 miles off course. Alright, let's go to our emergency section here. Okay, wind correction to parallel. We're 30 miles off. Find the distance off course on the outer scale, the distance you flew since last being on course on the inner scale. Okay, so it's going to be 30 outer scale, 300 inner scale. Okay, so we're going to match 30 to 30. I'm using my MB20 right now. It's a flight computer. All right, so match 30 to 30. read the correction angle at rate on outer scale. Okay, so rate 8 degrees. So it's going to be 8 right. Correction 8 right. And that gets us to parallel, but then we still have to make a further correction. Whoa. Okay, now we've gone too far the other way. Time. So we're about 5 minutes from needing to start the next shot. But then we need the correction to destination. So on the inner scale, distance remaining opposite distance off course outer scale. So 30 on outer. Distance remaining 300. Oh, it's exactly the same. So 8 plus 8, 16. Nice and round. All right, we're now between H2 and LOPI, so it's going to be 115. New course, 115 plus 16 equals 131. We're pretty much doing that right now. All right, let's level the wings here. All right, is that it? Wind drift corrections are made opposite to observed drift course in same magnitude. Now that's something different. That's a course adjustment. We don't need to do that right now. That's not every day we go to the bottom of that thing. That's what it's for, though. I mean, I'm happy to use it rather than not. All right, let's get the next landfall ready. So we want 920. Make sure we got Arcturus selected here. And I'll go back. I want to see if I can figure out what went wrong with our shot at 0900 with Arcturus. That was a little bit that was 3 degrees off. We should have gotten something to within a degree. So at the very end of this flight, we'll open up a little nav map and look at the flight. So we should, what we're probably going to see is a drift outwards to the north and then coming back down like this, assuming that we stay on track to the LOP intercept. 2 minutes to go. In the meantime, looking at our fuel, so we're now down from 90 to 30 on both sides. So that brings us down 120 on both sides. So we know we're 120 down. We should be able to calculate it. So we're 120 down on these tanks. We're about 20 down on these tanks, and we're about 110 or so down on the wing tanks. Alright, we got about 30 seconds or so to go. All right, 10 seconds to go. 5, 4, 3, 2, 1, now. The offset that we're expecting here is going to be huge, or it should be huge. If it's not, I'm going to be concerned. Should look like this, but be a little closer. All right, 44:18. .3 would be the number then. Okay, and now you can see we're converging. So it looks like now it's looking a little bit earlier, like maybe about 9:40. Or 9:50 maybe. Let's get Polaris just because we can. That should be really easy. See what the offset is that we got here. It's 2 degrees, 2.5 degrees. That's 150 nautical miles. And the azimuth was 105. Degrees 29 minutes. That's going to be our latitude. Close to it. Oh, yeah, that would help. Okay, so that's our new position. So we went this far in 20 minutes. No, that's not possible. So something I've done screwed up. So this was 40 minutes, right? Minutes would make sense. So then there's this distance. We should be near H2 right now. Now I'm really starting to get concerned because I'm getting numbers that are not making sense right now. Let's go to the landfall chart. Should be 150 nautical miles. Very weird. Almost at the point now we should be able to start looking for Bermuda. What the heck happened here? From H2, we were 63 nautical miles off. All right, so that's right. And yet somehow 150 just a little bit later. That doesn't make sense. At least we know what our latitude is. Well, it's in my best interest to fact check myself on that number because one of these numbers has to be wrong. So let's look up the Greenwich hour angle again. Let's see if it's 229.23. Okay. All right, there's right away a problem. .228.23. 145.48 for the star hour angle. That's correct. So let's add these then. 228 plus 145 minus 360 is going to be 1411. Subtract out 69 and make sure it is indeed 69. It is, okay. Minus 55 plus 360. 305. 35, 56, 33, 100. So 3 degrees declination, and I forget what D was, 33. Means the correction is 3 minutes. So new HC 3559. And then ZN equals Z. So I got 35.55, and let's check the time again. All right, we got 5 minutes until the next shot, and we're going east again. We're gonna get lost out here if I keep doing this. Let's see how that compares. It's even more off. I'm going to have to take a look at this after the fact and figure out what happened. My guess is there's something that I'm forgetting to factor in here. I don't have the formulas in front of me, so I'm actually going off of memory. So I'll have to do that. But anyway, it's coming up to the next Arcturus shot, and we really should start to look for Bermuda, because we're getting that close now. Nothing yet. shot starts in just under a minute. It's going to be time to change tanks again soon. Degrees 2 minutes. So that's going to be 49 degrees 58 minutes, 49.96. Ooh. Oh man. Okay, that's across. That's telling us that we are there now. So another 150 miles in 20 minutes means we're doing. Do I turn? Do I not? Let's see. How far are we from here? We went 400 miles in. When was the last time we did a check here? I did 820, 920, and 1020. 20 minutes. That might explain why they're off. Okay. So, alright, if this was 20 minutes later and I got the times wrong, that would put me 20 minutes further ahead than I thought, or about 200 miles. So then another 40 minutes. Okay, I'm convinced it's time to turn. Alright, so the time we got was 9:40. So we add azimuth plus 90 degrees, 200. So if we round it off to 50, that's 5 degrees off, 30 miles, which is like 5 minutes. So that's basically exactly what we did. So 30 miles off was what it was. And then it's going to be 200, right? Okay, and 20 minutes. That accounts for the time difference between my calculation on my celestial pre-computation form that we just did and my measurements that I actually got. So there were 20 minutes apart. Man, that is a big rookie mistake. Also, I need to note the time I turned. That was 9:42. Turned onto course 0942. And let's see how far away. We should be about here. So we're about 100 nautical miles away. "27 minutes. Alright, so our estimated arrival time is at 10:07. And, let's see, we're down to about 10 gallons before we switch to reserve tanks. So huge mistake on my fault. For some reason, I was thinking that this shot was to be made at 8 o'clock, this was to be made at 9 o'clock, this was to be made at 10 o'clock. What this means is that we now did celestial sights that were calculated 20 minutes off of the actual time that they occurred, which means that each one of these should be advanced about 20 minutes. So 20 minutes at 300 miles an hour means this one should be out here, this one should be out here. this one was correct. Time to look. Very much time to look. Let's do a clean shot at the top of the hour, just to be safe. We're going to set the location to be the destination. So that's 32, 22, 64, 41. This has saved me once before, it might do it again. Shot U1. Let's use Arcturus again. $10 o'clock. $285, so that translates to 105. Could you imagine the stress that the navigator would be under this kind of situation? 56 degrees, 30 minutes. We're lucky that we have Skyview Cafe. And then let's do Polaris again. That's always a 359. .96. Oh, wait a minute, hang on. Yeah, 31 degrees, 57 minutes. That was, I don't know why I converted it. Alright, do a shot at the top of the hour. We're going to have the shot assume the destination, which means it is going to tell us where we are relative to Bermuda. basically the way this works is we get a vector location of where we are relative to Bermuda, and then we turn when we get that position in the heading of where it is. And we should be so close to the island now that we should be able to get there no problem without accounting for like winds and stuff. We got about 5 minutes to go. Alright, it looks like it's finally time to abandon these tanks. We are 15, 10, 5. We've got like 3 gallons left. Switching over to reserves, which is planned. It's just that's our last tank. What are we at? 50 gallons. So we got 100 left on board. We got 1 hour left. What is that? Oh my gosh, am I looking at my own? No, that... There was definitely a second red... What is that? I guess it's a reflection of my nacelle off the moon or something. We got like 2 minutes. Alright, it's time. We are very far west, beginning an immediate turn east. West. That puts us about there. Let's do Polaris again. 2219. Okay, so that's not bad. 22 towards, so it should be negative is towards, right? Okay. Not bad, east-west. Not bad at all. Okay, so at 5 miles a minute, we've got 150 miles, so about 30 minutes. We may have continued a little bit further south, so a heading of about 85 degrees or so true should do it. So let's work this out. So this is true, but remember we need to go by magnetic, so that's like 15 degrees off, I believe. It's going to be 15, so have to add to that. So the compass heading would be about 105, but remember the wind is going to blow us further south, so we're going to compensate. Just doing an off-the-hand calculation here. Actually, the wind is pretty much from our backs. Yeah, I don't think we really need to do a wind correction. We'll just keep moving in this direction, and then let's do a shot at 10:15 to confirm that we're getting closer and we're on track. Before the sun comes up. Once the sun comes up, it's going to make things very difficult. Which is why we do these things at night. Hopefully we'll be able to see Bermuda by the time this site kicks off, and it won't be needed. Start getting bright soon. This we're getting close. It's also really starting to get high. I don't like to shoot things over 60 degrees. 59 degrees, 33 minutes. And we need an azimuth. For Polaris. let's see, I need to correct this for index error, so we need to add about 7 to that. Or 4, which makes it 37. Alright, let's see, Polaris, that's going to be a 1019. $31.56. So we just did a parallelogram. We were supposed to go further and then turn, but instead we turned early, about half an hour early. I'm going to have to look this over and watch this video again to figure out what happened, because I got myself really confused with a couple things going on that probably added up to be a bunch of distractions. See how much fuel we got left. Got about 70 gallons. It's about 45 minutes. We're about to start cutting into my actual reserves, which is something that I did not plan to do. Alright, 1 minute from the next Arcturus sighting. Start to see the morning light coming in now. This is... Oh. That is a light below the horizon. Okay, I think we've got it. Oh yeah, unmistakable. That has to be Bermuda. 5819. That makes us, let's see, 5919, and then 18 further than that, so 78 away. It's time for Polaris now. Almost 30 seconds. It's time. To 8. That means we're 12-2, so that's 12 in the direction of 359 right there, and then change to be 89. That means we were here, about 80 miles away. And we're now traveling at about 125 degrees azimuth. Maybe if we were like up here. Sun's about to come up. Let's split the distance. I'm a little worried that that's some sort of like weird aberration or something. Let's split the heading. So we think that we should be flying a heading of 100. Or this says fly a heading of 100. This says fly a heading of, hang on, 100 but add 15, so 115. And then we thought that it would be closer to 140, so like 135-ish. So let's set it right about there. And our distance off was 80 miles, which is 18 to 20 minutes, so 20 minutes beyond our sight time. Okay, that's still EST arrival 10:35. So that's about five minutes difference. I'm 90% sure that's Bermuda, but I've been tricked with these things before. But the moment of truth should be just a few minutes away. And it's got the distinctive J-hook too. We're going to lose the capability to do two-axis two-axis celestial navigation any second now. Alright, I'm getting... Alright, red and green lights. That's it. Without a doubt, 100%. That's it. Huh. Accumulate 50 hours flight time in a single pilot profile. Man, what a time to hit 50 hours. My goodness. Alright, we got it, we got it, we got it, we got it. In sight, 1025. Azimuth 160. Technically heading 160. Alright, now we can begin our descent. Descent checklist, throttles 15 inches. Prop governor 1600. And that's it until we hit 12,000 feet. Alright, let's see how much fuel we've got left. We've got about, we'll call it 25 and 25, so we got 50 gallons of fuel. At full speed, that'll last us about half an hour, but we've cut, and once you cut the throttles, I do have a descent fuel let's see, descent fuel. That's going to be in limitations. 1% of a full tank. Actually, you know what? At this point, it doesn't even matter. I'm going to say that we're within gliding distance of the runway now. Wow, look at that. In 5 minutes, it went from a possible aberration on the horizon to an island in the middle of the ocean. Well, folks, that is how you attempt to do celestial navigation, completely mess up, get lost, and then get yourself unlost. So I was really screwing up until I did what I call the lost procedure, and that's where you just set the dead reckoning location to the destination. Honestly, I feel like that's something that I could definitely do in the modern day. They don't do it back then because generally you want to know where you are at a given time, but I really don't care where I am just relative to the destination. So just like give me a vector and a distance, and that's basically all I need. Alright, so let's see, the wind is coming out of the northeast, so we can use either runway. It's basically straight across crosswind. So very quickly it should start getting bright. So we pretty much reached nautical twilight. And this really came down to the critical time too, because let me show you this. Okay, it looks like it's actually going to work. I'm expecting that it's going to tell you that you can't because it's nautical twilight. Once you do that, you can't get a sight off. So I'm really not going to know where I went wrong in real time. I'm going to have to go over this and basically check myself as I review this video and produce it. I will try to add on-screen captions that explain where I went wrong and why. And I think if there's one lesson to be learned, it's just do the dang autopilot. For goodness sake, just do the autopilot. I've already proven that it's possible to fly across the Pacific Ocean using celestial navigation with no autopilot. So there's really no reason why I need to be brute forcing this, without it. Because if anyone ever complains, oh, that plane didn't have autopilot. Okay, well, I flew across the Pacific Ocean without autopilot using celestial navigation. So I'm not really concerned. Alright, let's see, it's 10:30. How are we versus when I expected us to arrive? Are we actually going to get a shot? Let's see how accurate we were. Yeah, we did, 31:42. Has been at 31 degrees 57 minutes. (31:42). So we're 15. It says we're 15 north. Are we still going northeast? Yeah, we are. Okay, that might be a little bit inaccurate. But I I mean, celestial navigation was never 100% accurate for sure. Looks like we're finally down into the teens. It seems like every time I go outside, let me test this again. Every time I go outside, the tablet comes up. Maybe not. Let's see where our fuel is at. Yeah, it's basically no difference. Maybe down like 2 or 3 gallons. Nothing to worry about. So, I think however we flew it, that was definitely the range of this thing. We don't cut into our 50 gallon reserves, and this is just under, that's just above, and counting the whatever residual fuel might be in here. I'm going to say that this is basically 50. So we've used the maximum possible range today using the shorter tanks or the without the what is it called, drop tanks. I really hope that Flight Simulator doesn't pause the same way it did when I was taking off, because if it does that on landing, oh my gosh, I'm gonna crash. Because it remembered the control inputs while it was paused, which is really scary. So if it looks like it pauses, I'm gonna have to go hands off. myself what the runway numbers are. 12 and 30. Let's use 1, 2. We'll get into 30 right now. We'll do a loop. We're below 10,000 feet now, so at this point we can turn O2 off, and we'll leave the boost pumps on for landing. I guess the hypoxic effects did not occur because we definitely went below that. Alright, so we're coming down to about 10,000 feet right now. Down to about 175 miles an hour, which means we could throw the landing gear down if we wanted to. Alright, where's the runway at? Let's get the gear down. So let's see. Before landing, fuel selectors full as tanks, boost pumps on emergency, prop governor 2650 RPM. Auto rich. Intercooler shutter is open. As soon as we come around back to the runway, I'm gonna get the gear down. We're actually going slow enough for gear and flaps. Oh, we should also get our landing light on. Turn wing and tail lights on bright. We need to get below 175 and then we can throw the gear down. Ooh, that could make things a little bit interesting. There's gear, and once we get to 150 we can do the flaps. Would not recommend doing this. This is technically an instrument approach now, and we're hanging up. Lovely. So it's going to be basically impossible for me to land. Yeah, folks, don't try this at home. Yeah, this ain't happening. We're going to have to go around. Could have sworn I saw things disappearing down there. I'm gonna try the approach I use in my Mooney. Gonna do a gear down at the numbers, flaps down 1/3 on downwind, 2/3 base, full on final. Damn, there's some low clouds. Alright, let's do gear. Well, actually, no, we're low and we're slow. And now we're in the clouds again. There we go. All right. Finally. First notch of flaps now. I'm the plane owner now. now, so I can't mess up these landings anymore. Foot runway, no issue. No bets on the ground handling. That just absolutely sucks. But we're here about 20 minutes later than I think we predicted that we were going to be, which is not a problem. It's obviously that some of that circling that did it, plus just generally getting lost. All right, do we have a yellow line here? Yes, we do. Flap up. Stupid rudder pedals. I've never had luck with good rudder pedals, and I've tried ones that everybody is like, oh, you should try this one. I've tried it. It doesn't work. It sucks. It's not realistic. Alright. We'll pull out the map and figure out where the heck we are. Brake on, there we go. Oh, we should also clean up. So let's see, flaps up, fuel boost pumps. We can put those on normal. Also, now that we made it, light everything up. Right, prop governor full forward, coolant shutters full open. Oil shutters full open. Oop, didn't mean to do that. Landing light we need to keep on, and honestly wing and tail should be kept on too. Okay, so now we got to figure out where the heck we are. Looks like we're probably on this taxiway Echo, and we want to get to the FBO, so that's going to be a right on Alpha and then a left on Hotel or Juliet. I'm really surprised the sun hasn't come up, because I remembered it in Flight Simulator. It's like you see the sun a little bit, or you see a little bit of sunlight, and then it's like boom, it's day. Alright, let's see, are there any other turnoffs between here and Hotel or Juliet where we could get lost at? Nope, so we take the first turn on the left. Seriously, man? I always hate it when these random airport vehicles show up on taxiways. Alright, what are you gonna do? I don't have reverse. Absolutely absurd. This I can't stand this out of Microsoft Flight Simulator. It's horrible. Well, that worked out better than I thought it would. There we go. There's a turn. Can't see anything now, but in 2 minutes I'll be able to see it all. Alright, is there a fuel pump somewhere out there? Actually, well, in real life the answer is no. There was no avgas on Bermuda. There might be, ooh, we got a jet inbound. There's Jet A, but there's no 100 low red. And I think that's probably to try and stop people from doing what I just did. Whatever. I mean, we don't have a real need to fill up right now. This is tradition to always go to the pump. I'll just park next to the office and then we'll end it there. This is fine right here. Alright, we'll go ahead and shut down, so at this point we can turn off the landing lights and wing lights, tail lights. Alright, after landing checklist complete, I can go to shutdown and securing, and then after we shut down, we'll take a look at the results of the flight. I imagine it's going to look very ugly. Alright, oil dilution, we can skip that because it's not going to be cold. So stopping engines, throttle 1600 RPM. Let the impurities burn out. You should see the temperature come up a little bit here. Alright, that's good. Throttle back to 1200. Then boost pumps off. Let's get 1200, so I'm going to shut down so it's nice and clean. cluster auto cutoff. So let's see, 3 hours, 47 minutes. I think that's close to what I was saying. And that counts as a night landing. I can't believe I only made 4 night landings. The times don't make any sense to me, but whatever. Definitely not back to main menu. Propellers open. Propellers. Throttle open when propellers stop rotating. Magnetos off. Cockpit heat. I should have turned that off a long time ago. Right, close the flaps. We don't want any seabirds nesting in here. Get that nice subtropical air in here. It's still nice and warm and pretty much freezing where we left. I can't believe the sun hasn't come up yet. I think this is the first time we actually finished a flight and it was still dark out. Alright, so we're done. At this point we're going to go through our checklist of items that I need to grab, and we can debrief the flight a little bit. Alright, the first thing we want are the tank levels, and we can get those from the tablet. So we can now officially cheat the data in. So is it live data? Yes, it is. Okay. So we still have more than 50 on board. Get the final tank values. Alright, left main 6, right main 6. Left wing tank, looks like about 7. No, that's 9. Right wing tip, 9. Left reserve, 18. Right reserve, 23. Okay, so these are the ones that I haven't used yet. So yeah, that would have been 41. And then just some residual in the other tanks that, you know, obviously we could cycle through if we needed to. So let's get the final value on here. So that was exactly 70 less than the dry tank line. So that would have been 330. Whoops. Right there. Okay, so that's in line with the rest of these except for this one. I'm not sure exactly what happened there. But not bad. That's very accurate. And our flight distance was definitely the furthest that you want to take this thing, at least the longest time-wise. The next thing we need is the oxygen remaining. Does it even tell you what that is, or are we just going to have to straight up read it off? Yeah, there's no deflection, it's 0. Alright, the next thing we're going to grab are 2 files that are located in the bubble sextant folder. Those are actual route.csv and shotslog.csv. That will give us an accurate capture of all of the celestial navigation that we did. And this will also help me diagnose what I did wrong when I did wrong stuff. So that's there. And at last, it's finally time to cheat and look at little nav map. So I think we probably went north of the route and then we turned early. Yes, that's exactly what I thought happened. So he took off, flew right over Annapolis as I expected, transitioned over to the eastern shore as I had hoped, went right over US 13, saw that, right over Virginia Beach, saw Corolla, saw Kitty Hawk, and then we saw that turn, and I think I was confused and thought that I was looking at Route 64, and that wasn't the case. So that's when I figured out time-wise, hey, this doesn't make sense. So we did see Hatteras. 100% we saw Hatteras. So then there was a little bit of a delay. Then I'm like, all right, we're making more turn. And so then we're fine, except we don't trim the plane out. So then we start going off course here to pretty much due east. And then I find that we're 20 miles off course, and I'm like, hey, we need to correct this. So then I changed the heading, and we would have been all right. It looks like if we had extended the line, we would have reached our successful LOP intercept. But for some reason, it looks like I found it 30 minutes early, and I'm not sure why that happened. That's what we have to investigate, what went wrong. So then I turned on that LOP intercept. If I had turned here, I would have been absolutely fine. And then I did my shot here and realized, whoa, we are way east of where we should be. Looks like we were also a little bit north, and see if that matches what we have in Google Earth, because I think we were a little bit south. Nope, we were a little bit north the whole time. So the path in here went something like this. Yeah, that's basically exactly what we did. So we turned back what I thought was due east, and then I reminded myself, no, it's not due east because it's compass east. So you'd have to add 15 degrees to that. So then I think this was the time that we thought we saw the light from out here. I am curious to know, can we add range rings to this? Yes. Okay. So we saw Bermuda from about 60 miles out. Started to turn towards that, and I was like, hey, maybe I should angle more this way, because the true direction that I was thinking it was like over here. And then when I got within whatever this distance is, looks like maybe 20 miles, it became unmistakable. Then we went in, spiraled in. That wasn't good enough, so then we did 2 more spirals. Still had to go around, so we flew a traffic pattern. I'm actually really impressed that I was able to fly this good a traffic pattern at night in IMC. That's ridiculously stupid, and somehow it worked out. But anyway, yep, pretty good landing. So one question is, what happened here? That's the only question I have is what happened here. Everything else worked exactly the way it should have. So that's it. I'm just going to basically export this thing now to exactly where I want to. Obviously, you can see we saved ourselves, because right about when I realized that I wasn't seeing Bermuda, we did the emergency shot, and that saved us. If we didn't do that, we would have run out of fuel somewhere in this area in about 16,000 feet of water. That doesn't sound very appealing, but it worked. So this is pretty much the end of the video. Thank you all for joining me on this transoceanic kind of expedition again. These are always really fun. They're extremely rewarding. I didn't want to say it when we were getting close to Bermuda, because I was like, watch it be some reflection off of a planet or something. But no, it was definitely it. So it turned out very well. That I ended up exactly where I thought I was, and it's just so rewarding when you pick that island out of the entire ocean. Very, very rewarding. You know, we've got a very, very nice morning on Bermuda. You can start to see things. Thank you all for joining me. I've been Dr. Aeronautics. If you liked this, please like the video. Please subscribe to my channel. It helps me out. I finally reached my first monetization milestone. I got to apply to the YouTube partnership program. I'm finally in it now, which means I can finally make money. So thank you all for supporting me, if you've been supporting me in the past to get me here. And if not, welcome aboard. Hope you enjoyed my channel and got to learn something from my mistakes. All right, bye-bye.